So today we are going to study three fundamentals law of science, right? Namely, they are law of conservation of matter, the law of conservation of energy, and law of conservation of matter and energy, which is a combination of these two laws. So to start the discussion, I want to start with a simple experiment, which is shown over here. Here, what we are doing is we are burning magnesium, right? It's a metallic magnesium burning in oxygen. Okay, so we are burning the magnesium in oxygen, and as a result, some white powder is formed, right? Which is called magnesium oxide, right? And if you look at the weight of the magnesium oxide, you will find that it is greater than the weight of the magnesium which is burned. Okay, so from where did this magnesium oxide has a higher weight than the burned magnesium? The idea here is simple, that actually oxygen also combined with magnesium to form magnesium oxide, and when we add up the mass of magnesium to the mass of oxygen which was used, that is equal to the mass of magnesium oxide. Okay, so that is equal to the mass of magnesium oxide, and there are a lot of experiments which we have performed, and we find that every time the mass of magnesium oxide is exactly the sum of masses of magnesium and oxygen that combines to form this, right? So that brings us our first law, which says the law of conservation of matter. Okay, it says that matter cannot be created or destroyed in a chemical reaction or physical changes, right? So whatever chemical reaction takes place here, right, the mass of the matter before and after are exactly same. Okay, it may be they have combined to give a different substance, right? But the total mass, it remains the same, and that is what we simply call the law of conservation of matter. Okay, the second law which is useful is law of conservation of energy, which says that energy cannot be created nor destroyed, and it can only be converted from one form to another. And there are several examples you may be aware of already. So for example, we have this battery, right, which has a chemical energy inside it, right? When we connect it to the bulb, basically this chemical energy gets converted into electrical energy, right? And then it travels to the bulb, and there it converts into light energy, and some heat is also formed, right? So what is happening here, that whatever was the starting chemical energy stored in the cell basically gets finally converted to the light energy and the heat energy, right, in some process. So the total sum of the energy which is there, so the chemical energy which got converted to two things, the heat and light, is same, right? So total energy always remains the constant, and it is not created nor destroyed, right? So it does not increase or decrease. That's what we mean to say that energy cannot be created or destroyed, right? So whatever is the starting energy, the total energy in the final configuration also remains the same, and that is called law of conservation of energy. Now, when we combine this with the law of conservation of matter, we can arrive at something which is called law of conservation of matter and energy, right? So the question which we ask is that, anybody, any object which has a mass, which means it has a matter, what will happen if we convert all the mass into energy, right? So I do not exist, right? So in that case, the conversion factor is given by the Einstein's equation, which is called equal to mc square, right? Where m is the mass which we want to convert, and c is the velocity of light, right? So we will not go into the detail of this, but if we somehow convert all the matter into energy so that the matter does not exist, right? You get a huge amount of energy out, and that is the mass and energy are equivalent things, right? So we can convert the mass back to energy, and in some cases, energy back to the mass as well, right? So this compound amount of matter and energy in the universe is fixed, and that is what we call law of conservation of matter and energy, right? So it's just a combination of these two laws which we discussed, the law of conservation of matter, and if somehow the matter gets transformed into energy, which usually happens in case of nuclear reactions, right? Like a nuclear bomb when we make it, right? So whatever the mass loss basically get converted into huge amount of energy, and that can be calculated using the Einstein's equation equal to mc square. So this combination of law of conservation of matter and law of conservation of energy yields the third law, which is the law of conservation of matter and energy. Okay, so as we said, the matter in a chemical process or a physical process is always conserved. The initial mass of the total matter used in the chemical reaction is equal to the final mass of the product which is formed during the chemical reaction, right? And the energy of a different forms, right? Like the chemical energy converting into light energy and heat energy in this example, right? Will be exactly same, right? So if we have, for example, 100 joules of chemical energy, and let's say we converted it to 80 joules of light energy and 20 joules of heat energy, basically they will sum up to the exactly 100, right? So that is our law of conservation of energy. And as we mentioned in the previous section, that it is possible to convert the energy from one form to another, right? So that is the maths which law provides you to ensure that the total energy remains constant, and that is what we call law of conservation of energy. And when we combine these two laws, the law of conservation of matter with the law of conservation of energy, what we have is the law of conservation of matter and energy, right? So when we convert all the matter, whatever the amount is into energy, we get a very huge amount of energy, but the total sum of the energy remains the same.